Good morning, dear students. We already discussed about the capacitor and capacitance of a parallel plate capacitor. We already derived the capacitance of a parallel plate capacitor, right? That is the capacitance of a parallel plate capacitor. Parallel plate capacitor. What is parallel plate capacitor? Parallel plate capacitor means the two plates are separated by a small distance. One plate having the positive charge and another plate having the negative charge. Okay, that is the capacitance of a parallel plate capacitor is epsilon naught A by D. Right? If the parallel plate capacitor it is in air, air medium. Correct? It is air medium. If it is in medium, if it is in medium, then the epsilon naught A divided by D. Okay. The absolute permittivity means this is epsilon naught means relative permittivity of the mediums. If 1 by 2 gives, this is 1, this is 2. So if it is gives 1 by 2 gives the Cm by Ca. Okay. The relative permittivity is also defined as the capacitance of a parallel plate capacitor is in medium to the capacitance of the parallel plate capacitor in air medium. Okay. Just I repeat once again. Relative permittivity is in terms of capacitance. Relative permittivity is defined as the capacitance of a parallel plate capacitor in medium to the capacitance of a parallel plate capacitor in air medium. Okay. So this is about the one mark important question. Write the relation relativity, the absolute permittivity in capacitance. Okay. Next we will have the energy stored in a capacitance or capacitor. Right. Derive the expression for energy stored in a capacitor. Derive the energy stored in a capacitor. Derive the energy stored in a capacitor. Derive the energy stored in a capacitor. It is a 5 marks very important derivation. Okay. Derive the expression for energy stored in a capacitor. Just we have the diagrams. So one plate having the positive Q and another plate having the negative Q. It means one plate have the positive charge, one plate have the negative charge. That means the capacitor, or simply say the parallel plate capacitor. The two plates are having the opposite charges separated by small distance. This is the small distance D. Okay. Now we have the external battery. Now we have the external battery connected to the capacitor. This is capacitor C. This is one battery, that is potential in P. P is the potential difference. Okay. This is called battery. Correct. Consider a parallel plate capacitor or simply capacitor. Parallel plate capacitor of a capacitance C. Right? Let Q is the charge stored. Q is the charge stored in the capacitor. In the capacitor. Right? Q is the charge stored in the capacitor. P, potential difference. Potential difference. Okay, P is the potential difference. Okay, we have the by the definition of capacitance. By the definition of capacitance, it has to be by the definition of capacitance. C equal to has to be Q by V. Correct. In terms of P, P equal to Q by C. Right? Q by C. Correct. So if it is the potential difference is equal to the charge by capacitance. Correct. We have the small work done. We have the small work done. We have the small work done. That is small work done dW is equal to P into dQ. P into dQ. Already you know the work done in terms of the P and Q. Correct? So P equal to that is Q by C, that is dQ. Okay, we have the small work done dW is equal to P into dQ. Correct? So dW equal to P is substituted as a Q by C. That is equation number. This is equation number 2. Sorry, this is equation number. This is 1. This is 2. Okay. This is equation number 2. We'll have the total work done. Howda? In a small work done ಬೇಕಾಗಿಲ್ಲ. We'll have the total work done to transfer the total charge from one plate to another plate. So the total charge is saving. Yes, the total charge is that Q is the total charge stored in the capacitor from the potential difference P. P ಅಥವಾ potential difference ಅಥವಾ ಬ್ಯಾಟರಿ ಇಂದ ಅಪ್ಲೈ ಮಾಡಿದಾಗ ಆ ಕೆಪಾಸಿಟರ್ ಒಳಗೆ ಎಷ್ಟು ಚಾರ್ಜ್ ಸ್ಟೋರ್ ಆಗ್ತದೆ, that is Q. Q is the total charge stored in the capacitor. We have the total work done. Total work done to store the charge Q. To store the charge Q. Okay, we have the integrating equation number 2 between the limits that is 0 to Q. ಹೌದಾ? మరి ಇನಿಷಿಯಲ್ ಕೆಪಾಸಿಟನ್ಸ್ ಎಷ್ಟು ಇರ್ತದ ಅಥವಾ ಚಾರ್ಜ್ ಎಷ್ಟು ಇರ್ತದ? 0. ಆಮೇಲೆ ಏನಾಗ್ತದೆ, ಲಾಸ್ಟ್ಲಿ ದ ಪೊಟೆನ್ಶಿಯಲ್ ಡಿಫರೆನ್ಸ್ ಇಸ್ ಅಪ್ಲೈಡ್, ದ ಚಾರ್ಜಸ್ ಆರ್ ಸ್ಟೋರ್ಡ್ ಇನ್ ದ ಕೆಪಾಸಿಟರ್ ಬೈ ಬಿಟ್ ಸ್ಲೋಲಿ ಒಂದೊಂದು ಸ್ಟೋರ್ ಆಗ್ತಾ ಹೋಗ್ತಾವ. ಫೈನಲಿ ಏನಾಗ್ತದೆ, ದ ಕ್ಯಾಪಿಟಲ್ Q ಚಾರ್ಜ್ ಇಸ್ ಸ್ಟೋರ್ಡ್ ಇನ್ ದ ಕೆಪಾಸಿಟರ್. ರೈಟ್? ವಿಲ್ ಹ್ಯಾವ್ ದ ಇಂಟಿಗ್ರೇಟಿಂಗ್ ಆಫ್ ದಿಸ್ ಇಕ್ವೇಷನ್. ಸೊ ನೋಡ್ರಿ, right? So integration of Q by C into D. Correct? So Q by C into dQ, that is 0 to Q. Okay? So integration of dW is W. Correct? Q is constant. Q is the charge constant. The C is the constant that is taken as outside. C is the constant. That's why integration term is only the Q. Okay, integration term is that is Q only. You know that integration of x raised to n is x raised to n plus 1 divided by n plus 1. You already derived this. You already know this equation. So this is x raised to n is equal to x raised to n plus 1 and divided by n plus 1. It is a formula. Here we will apply. So that is 1 by c is equal to, that is here q equal to 1 plus 1 divided by 1 plus 1. Here n equal to 1 because anything raised to q is nothing but raised to n equal to 1 here. So that's why q raised to 1 plus 1 divided by 1 plus 1. So the limits 0 to q. Okay. 1 by c, that is q square by 2. 0 to q. Correct. So we substitute the higher limit, upper limit to the lower limit. Correct. So w is equal to 1 by c, that is q is substituted q only, q square by 2 minus 0 because the upper limit minus lower limit. Okay. So the work done is equal to q square by 2. So this work done is stored as energy. This work done is stored as energy in the capacitor. That is indicated as U. U is equal to W. U equal to 1 by 2 Q square. Q square by 2c. Correct. This is the energy stored in a capacitor. Okay. So in the integration q ಆಗ್ತದೆ q raised to 1 ಆಗ್ತದೆ q raised to 1 plus 1 divided by 1 plus 1. So q square by 2 ಆಗ್ತದೆ, substituting the upper limit minus lower limit. So q square by 2c ಉಳಿತದೆ. This work done is stored as energy. Energy means U. Okay. U equal to q square by 2c. Okay. We'll have one more time ನೋಡ್ರಿ ಎಲ್ಲರೂ ಒಂದ್ಸಲ ನೋಡ್ಕೊಂಡ್ಬಿಡೋದು. ಇನ್ನೊಂದ್ಸಲ derive the expression for energy stored in the capacitor. Correct. This is the capacitor. One is having the positive plate, one is having the negative plate. Here the potential difference is applied to the capacitor. The C is the capacitance of the capacitor. By the definition of capacitor, C equal to Q by P. P equal to Q by C. Correct. We have the small work done. Now small work done is equal to dW. dW is equal to P into Q. It hang on. So you know that already the potential equal to W by Q. Correct. So that is work done equal to P into Q. You already know this equation. The electric potential definition. Okay. So dW equal to P into dQ. So dQ is a small charge. dW equal to P and substitute ಮಾಡ್ತೀವಿ, Q by C substitute ಮಾಡ್ತೀವಿ, dQ. We'll have the ನಮಗೆ ಬೇಕಾದ total work done ಬೇಕು, small work done ಬೇಕಾಗಿಲ್ಲ. So we'll have the total work done to store the charge Q. ಹೌದಾ? From 0 to Q store ಆಗ್ತದೆ. Initially capacitance charge ಇರ್ತದೆ 0. Finally ಏನಾಗ್ತದೆ Q ಇರ್ತದೆ. So integrating the above equation 2, we'll have this one. Integration of dW is W. C is taken constant. So Q means integration of Q is nothing but Q square by 2. So we will have the energy stored in the capacitor. Okay. So once I record next time next concept called capacitors in series and parallel. This is nothing but energy stored in the capacitor. Okay na? ಇಲ್ಲಿ ನೋಡ್ರಿ ಇನ್ನೂ ಸ್ವಲ್ಪ ಆ ಇಕ್ವೇಶನ್ ಅನ್ನು ಮಾಡಿಫೈ ಮಾಡೋಣ ಈಗ ನೋಡ್ಕೊಡ್ರಿ. So U equal to ಏನು ಬರ್ತದೆ? U equal to 1 Q square by 2C. ನಿಮಗೆ ಗೊತ್ತಿರೋದು C equal to ಏನು ತುಂಬೋದು ನಾವು? C equal to Q by B. ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದ್ರೆ ಏನಾಗ್ತದೆ? C equal to Q by B. ಈ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡೋದಕ್ಕೆ ಏನಾಗ್ತದೆ C equal to Q square, but 2 means 2 into C means Q by V, right? So ಇಲ್ಲಿ ಏನಾಗ್ತದೆ Q ಮತ್ತು 1 Q ಕ್ಯಾನ್ಸಲ್ ಆಗ್ತದೆ. ನೆಕ್ಸ್ಟ್ V ಮೇಲೆ ಬರ್ತದೆ, that is 1 by 2 into Q into V. So 1 by 2 ಉಳಿತದೆ. ಈ 1 Q ಕ್ಯಾನ್ಸಲ್ ಆಗ್ತದೆ, 1 Q ಆಲ್ರೆಡಿ ಉಳಿತದೆ. Next V is taken to be in the numerator, that is 1 by 2 into QV. This is also one of the important relation between the Q and V. Okay, Q means charge stored and V means the potential difference is stored. Okay, so it is also one derivation. This is also one. This is also one. Okay, if we substitute it as a V, okay, if we substitute it as a V, that is Q by V, that means Q square by 2C comes. Okay, next we have the capacitors in series and capacitors in parallel. That is said to be combinations of capacitors. Okay, combinations of capacitors. Next one is combinations of capacitors. Means combinations of capacitors. Combinations of capacitors. Capacitors are combinated in the two groups. One is series combination, one is parallel combination. For example, you notice even capacitor ಅದ ಕರೆಕ್ಟ್. ನಮಗ ಒಂದು 2 ಕೆಪಾಸಿಟರ್ಸ್ ಅದಾವ ಅಥವಾ 3 ಕೆಪಾಸಿಟರ್ಸ್ ಅದಾವ ತಿಳ್ಕೊಂಡ್ರೆ ಹೆಂಗ್ ಕಾಂಬಿನೇಷನ್ ಮಾಡಬಹುದು? ಒಂದು ಸೀರೀಸ್ ಕಾಂಬಿನೇಷನ್, ಒಂದು ಪ್ಯಾರಲಲ್ ಕಾಂಬಿನೇಷನ್, ಡಿಪೆಂಡಿಂಗ್ ಆನ್ ನಮಗೆ ಯಾವ ರೀತಿ ಬೇಕಾಗಿದೆ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ನಾವು ಅಂಗಡಿ ಒಳಗೆ ಏನಾದ್ರು ತಗೊಳಕ್ ಹೋಗ್ತೀವಿ, ಒಂದು ಬಲ್ಬ್ ತಿಳ್ಕೊಂಡ್ರೆ ಒಂದು ಬಲ್ಬ್ 5 ವಾಟ್ ನಮಗೆ 10 ವಾಟ್ ಬೇಕಾಗಿದೆ. ಸೊ 10 ವಾಟ್ ಬಲ್ಬ್ ಅಲ್ಲಿ ಇರಲ್ಲ. ನಾವು ಅದಕ್ಕೆ ಏನ್ ಮಾಡ್ತೀವಿ, ಅವ್ರ ಅಂಗಡಿಯವ್ರು ಏನಂತಾರೋ 5 ವಾಟ್ ದ 2 ಬಲ್ಬ್ಸ್ ತಗೋರಿ 10 ವಾಟ್ ಆಗ್ತದ ಅಂತ. ಸೊ 5 ವಾಟ್ ದು 2 ತಗೊಳ ಅಂದ್ರೆ ಏನಾಗ್ತದೆ 10 ವಾಟ್ಸ್ ಆಗ್ತದೆ. ಅದೇ ರೀತಿಯಾಗಿ ಸೊ ಇಫ್ ದ ಕೆಪಾಸಿಟರ್ ಬೇರೆ ಬೇರೆ ತರ ಇರಬಹುದು, ಬೇರೆ ಬೇರೆ ವ್ಯಾಲ್ಯೂ ಇರಬಹುದು, ಬಟ್ ಅವ್ನ ಕಾಂಬಿನೇಷನ್ ಮಾಡಿದ್ರೆ ನಮ್ಗೆ ಏನ್ ಬರ್ಬೋದು, ಡಿಸೈರ್ಡ್ ಅಂದ್ರೆ ನಮಗೆ ಬೇಕಾಗಿರೋದು ವ್ಯಾಲ್ಯೂ ಅಂತ ಸಿಗ್ಬೋದು. ದಟ್ ಈಸ್ ಕಾಂಬಿನೇಷನ್ ಆಫ್ ಕೆಪಾಸಿಟರ್ಸ್. ಅದಕ್ಕೆ ನಾವು ಕಾಂಬಿನೇಷನ್ ಮಾಡಬಹುದು. ಸೊ ಈಗ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ನಮಗೆ ಬೇಕಾಗಿರುವಂತ ವ್ಯಾಲ್ಯೂ ಸಿಗ್ಲಿಲ್ಲ ಅಂದ್ರೆ ನಾವು ಇದ್ದಿದ್ದಂತ ವ್ಯಾಲ್ಯೂಸ್ ಅನ್ನ ತಗೊಂಡು ನಾವು ಕಾಂಬಿನೇಷನ್ ಮಾಡಬೇಕು. ಓಕೆ, ಅವಾಗ ನಮ್ಗೆ ಏನ್ ಬೇಕಾಗಿದ್ದ ವ್ಯಾಲ್ಯೂ ಏನಂತದ ಸಿಗ್ತದೆ. We have the capacitor combinations of capacitors to get the desired value of the capacitors. That is series, that is parallel. Okay, combinations of series capacitors is the two types. One is series combination, that is series combination. Okay, series combination means in the series combination, in this combination the two capacitors is connected end to end, end to end connection. That means like this. This is C1, this is C2, next this is C3. This is the series combination. Okay, in this combination the capacitors are connected end to end. Okay, this is one end is connected to the next end of the capacitor C2. This end is connected to the next capacitor. This is series combination. In this series combination, charge is same. Q is same. Q means charge. Q is same, charge is same for both three capacitors. And V, potential difference is different. Potential difference is different for different capacitors. Correct? Potential difference is different. Q means charge is same. Okay? In this series combination, we'll have the parallel combination. We'll have the parallel combination. We'll have the parallel combination. In this combination, the two ends of the capacitors are connected to each other. Okay, both the ends are connected. Two ends means two ends of the capacitors are connected to the two ends of the another capacitor. For example, like this. This is capacitor C1. This is capacitor C2. This is C2. That means two ends are connected to each other. Okay, E and E connect together, right? So this is parallel combination. This is called series combination. In this combination, the V is same. V means potential difference is same. That means like this. ಎರಡು capacitor ಗೆ C1 and C2, the potential difference is same. Next is ಏನು change ಇರ್ತದ? Q. That means charge is different. ಇಲ್ಲಿ charge ಇರ್ತದ ಬೇರೆ, ಇರ್ತದ ಬೇರೆ. For example, this charge Q1, this is charge Q. But the potential value is same for this also, P is same. Okay, in series combination, charge is same. Q ಎಲ್ಲ ಕಡೆ same ಇರ್ತದೆ. That means like this. Q, here also Q, here also Q. Okay, so V is different. This is V1, this is V2, this is V2. Okay, potential difference is different. Correct? In series combination, end to end connection, only one end is connected. In there, both the ends are connecting to each other. Correct? In series combination, adu parallel combination. Once ನೋಡ್ಕೊಂಡ್ಬಿಡ್ಲಿ. Okay, this is nothing but combinations of capacitors. One is series combination, one is parallel combination. Now we will discuss the two definitions of the capacitors in series combination or parallel combination. ಏನಂದ್ರೆ ಅದು effective capacitance. Okay, effective capacitance or effective capacitor. It is the capacitor. It is the capacitance from which it has the capacitance of the group of capacitors. Okay, effective capacitance is nothing but it is the capacitance of the group of capacitors. ಈಗ ನೀವು ಇದೇ ನಾ ಆಲ್ರೆಡಿ 3 ಗ್ರೂಪ್ಸ್ ಮಾಡಿದ್ರೆ 3 ಕೆಪಾಸಿಟನ್ಸ್ ಅನ್ನು ಸೇವ್ ಮಾಡಿದ್ದು ಅದ್ರ ಬದಿ ಏನು ತಗೊಳ್ಳೋದು ಒಂದೇ ಒಂದು ಕೆಪಾಸಿಟನ್ಸ್ ಅನ್ನ ತಗೊಳ್ಳೋದು. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ನಮಗೆ ಬೇಕಾಗಿರೋದು 2000 ಲೀಟರ್ ಅಂತ ತಿಳ್ಕೊಡ್ರಿ. 2000 ಲೀಟರ್ ಒಂದು ನಾವು ತಗೊಳ್ತಿದ್ರೆ ಏನಂತಿ ನಾವು 3 ತಗೊಂಡಿದ್ದೀವಿ 500 500 500 ಅಥವಾ 4 ತಗೊಂಡಿದ್ದೀವಿ ತಿಳ್ಕೊಡ್ರಿ. 500 ಲೀಟರ್ಸ್ ಒಂದು ಏನಂತಿ ಸಿಂಟೆಕ್ಸ್ ತಗೊಂಡಿದ್ದೀವಿ 500 500 500 4 ತಗೋಬರ್ಲಿ ಒಂದೇ ತಗೊಳ್ಬೇಕು ಅಂದ್ರೆ 2000 ಲೀಟರ್ ಒಂದು ತಗೋಬೇಕು. ಸೊ ದಟ್ ಈಸ್ it is the capacitance of the group of capacitance. A group ಕಿಂತ ಒಂದು ತಗೊಳ್ಳೋದು ಏನಂತೀವಿ it is the effective capacitance. ಇನ್ನೇನ್ರಿ effective value of the capacitance. In equivalent capacitor or effective capacitor equivalent capacitor or effective capacitor. It is the single value of capacitor. Is the single value of the capacitor which has the same value of the group of capacitors Okay, it is a single value of the capacitor which has the same value of the group of capacitors. Nothing but ಯಾವ ರೀತಿ ಅಂತ ನೋಡ್ರಿ ನೀವು ಕಾಂಬಿನೇಷನ್ ಮಾಡಿ ತೋರಿಸ್ತಾರೆ ಅಥವಾ ಅವಾಗ ಇದೆ ಆಗ್ತದೆ. ಈ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಇಲ್ಲಿ 2 ಮತ್ತು 2 ಅದ ತಿಳ್ಕೊಳ್ಳಿ ನಮಗೆ 4 ಬೇಕಾಗಿದೆ ಒಂದು ಜೋಡಿಸಬಹುದು. ದಿಸ್ ಇಸ್ ನಥಿಂಗ್ ಬಟ್ ಓಕೆ ಇವೆರಡು ರಿಪ್ಲೇಸ್ ಮಾಡಿ ನಾವು ಏನು ಮಾಡೋದು ಒಂದು ಸಿಂಗಲ್ ವ್ಯಾಲ್ಯೂ ಅನ್ನ ತಗೊಳ್ಳೋದು. This is called effective capacitor or effective capacitor. Okay, ಅಥವಾ equivalent capacitor. ಇವೆರಡನ್ನ ರಿಪ್ಲೇಸ್ ಮಾಡಿ ಏನು ಮಾಡಬಹುದು ಒಂದು ವ್ಯಾಲ್ಯೂ ಅನ್ನ ತಗೊಳ್ಳೋದು. Okay, so it is a single value of capacitor which has the same value of the capacitors. ನಾವು ಎರಡು ಜೋಡಿಸ್ತಿದ್ವಿ ನಾವು 4 ಅನ್ನ ಒಂದೇ ಜೋಡಿಸೋದು. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ನೆಕ್ಸ್ಟ್ ಒಂದು ಇಲ್ಲಿ 5 ಇದೆ, ನೆಕ್ಸ್ಟ್ ಇಲ್ಲಿ 10 ಹೌದಾ. ನಾವು ಎರಡು ಕೂಡ ಏನಕ್ಕೆ ಜೋಡಿಸಬಹುದು ಸೊ 15 ಅನ್ನೋದು ಒಂದೇ ಜೋಡಿಸಬಹುದು. ಓಕೆ ಗೊತ್ತಾಯ್ತಿಲ್ಲ ಇದು. ಸೊ ಇಲ್ಲಿ 5 ಅದ ಇಲ್ಲಿ 10 ಅದ ಎರಡು ಕೆಪಾಸಿಟನ್ಸ್ ಆಗ್ತಾವ. ಆದ್ರೆ ನಮ್ಗೆ ಏನ್ ಬೇಕಾಗಿದೆ ಒಂದು ಜೋಡಿಸಬೇಕಾದ್ರೆ ಏನ್ ತಗೋಬೇಕು ನಾವು ಕೆಪಾಸಿಟನ್ಸ್ 15 ಅನ್ನ ಜೋಡಿಸಬಹುದು ನೋಡಿ. ದಟ್ ಇಸ್ ಈಕ್ವಲೆಂಟ್ ಕೆಪಾಸಿಟರ್. ಓಕೆ ಸೊ ಎರಡು ನೋಡ್ರಿ ಡೆಫಿನಿಷನ್ ಇಂಪಾರ್ಟೆಂಟ್ ಆಗ್ತದೆ. while deriving the capacitors in series and capacitors in parallel. Capacitors in series ಮತ್ತು parallel derive ಮಾಡೋದ್ರಿಂದ ಈ ಎರಡು ಡೆಫಿನಿಷನ್ಸ್ ಯೂಸ್ ಆಗ್ತವೆ. What is effective capacitance or effective capacitor? It is the capacitance of the group of capacitor. Total ಈಗ ಒಂದು ಗ್ರೂಪ್ ದಾಗ ಎಷ್ಟು ಕೆಪಾಸಿಟನ್ಸ್ ಇರುತ್ತಲ್ಲ ಅದ್ರ ಒಂದೇ ಒಂದು ವ್ಯಾಲ್ಯೂ ಇರ್ತೀವಿ ಒಂದೇ effective capacitor. In equivalent capacitor ಏನು ನಾವು 2 or more ಕೆಪಾಸಿಟರ್ ಅನ್ನು ತಗೊಳ್ತಿದ್ದಾರೆ ಅದನ್ನೆಲ್ಲ ಸೇರಿಸಿ ಒಂದೇ ಒಂದು ವ್ಯಾಲ್ಯೂ ಇಂದ ಕೆಪಾಸಿಟರ್ ಅನ್ನು ತಗೊಳ್ತೀವಿ. It is a single value of the capacitor which has the same value of the group of capacitors. Okay na? So ನೋಡ್ಕೊಡ್ರಿ we will have the ಇವತ್ತಿಗೆ ಏನೇನ್ ಮಾಡಿದ್ರು there are the energy stored in the capacitor and combination of capacitors, series combination and parallel combination. Next lastly the equivalent capacitance and equivalent capacitor effective. Okay, these are the two definitions are very important. Okay, next class ಅಲ್ಲಿ ನಾವು ಏನು ಮಾಡೋದು capacitors in series capacitors in parallel ನೋಡೋಣ. Okay, so ಕರೆಕ್ಟ್ ಆಗಿ ನೋಡ್ಕೊಡ್ರಿ ವಿಡಿಯೋಸ್ ಆಮೇಲೆ ಕರೆಕ್ಟ್ ಆಗಿ ನೋಟ್ಸ್ ಕೊಡ್ರಿ ಫಾಲೋ ಮಾಡಿ. Okay, thank you.